Hi guys, welcome back to the Distinction Factory where we make our mark, and we are continuing with function notation comparison of two different graphs. In our previous videos, I explained to you guys the straight line test, the comparison between of one graph rather, and we looked at the question that's on the screen currently. Now we're going to go on to our next question, and it says that we have the graphs of f of x, which is equal to a sine x. That refers to this graph down here. And then we have g of x, which is equal to cos x plus 1, and that refers to this graph here. Now let's look at the question. The question says, where is g of x minus f of x equal to 2? So what that means is they are talking about the y values of g of x, which is the cos graph, minus the y values of your sine graph, and when you subtract those values, they should give you 2 as an answer. Alright, so for this part here, we're going to use our vertical line test. I have my imaginary ruler on the right hand side here, and we're not going to section the graph off because we can clearly tell our y values because they draw up a grid quite nicely for us in this case. So we're just going to take our ruler and run it through. So let's start on the left hand side and move it across to the right hand side. So here's the first part where it touches, and we've got our y value to be 2 on g of x and our y value of f of x to be down here at 0. So when we're minusing those values, we end up with 2 minus 0, and that does equal to 2. So this does answer our question at this specific point here, which is when x is equal to 0. Let me just highlight this so we know it's answering our question. Then if I go on to the next bits, let's look at this part here and this part here. So these two places, when I subtract their values, it will not give me 0. Sorry, it will not give me 2 rather, because this is slightly less than 2 and this is slightly higher than 0. So when I minus them, I know I'm not going to get 2 as an answer. Let's go on to the next part. Let's look at this point of intersection of both of our graphs. G of x has a y value of 1, and f of x also has a y value of 1. So when I minus them from each other, I get 0. So that does not answer our question, so I will not highlight it. Let's go on to our next part. Let's look at when x is 180. Now, if we're looking at our g of x graph, which is the cos graph, its x value is 180, but the y value is here at 0. And if we're looking at the sine graph, its y value is also going to be 0. And when I say 0 minus 0, I end up with 0, but I was supposed to end up with 2. So that does not answer the question. Let's go on to our next bits. Let's go on to 270. Let's look at g of x first, which is up here, and that has a y value of 1, minus the corresponding y value of the sine graph, which is down here, and that is at -1. And when I say 1 minus -1, I do end up with 2 as my answer. So this, when x is 270, it does answer my question. So let me just highlight that part. Then let's go on to our next bit. Let's do when x is 360. So I'm looking at this part here and this part here. At this part, my g of x graph, or rather the cos graph, has a y value which is at 2. And the sine graph has a y value of 0. And when I minus those, I do end up with 2 as an answer, which again does answer my question. So I'll highlight this bit as well. So I have 3 different x values for where my y of g of x and I subtract the y of f of x gives me 2. So I'll have to write out all 3 of those values. Let me just delete my ruler. And now we can represent our answer. We are going to tell them that x will have to be equal to all 3 of those values. So we'll say that x is equal to 0, or x is equal to 270, for x is equal to 360 degrees. And that will be our answer for this question. I hope you guys enjoyed this video. You can catch us on our next one. Thank you.